So welcome to the 992nd monthly meeting. Happy New Year to all of you.
Happy New Year.
We had a wonderful New Year's party. So just to start away, Eileen, she was the main organizer for this. Couple of words from you on the party that we had, turning around the.
Well, I think
Time.
everybody enjoyed coming for New Year's Day as opposed to New Year's Eve, especially since we had rain, freezing rain New Year's Eve, so it's much better. But we had certainly more than 40 people, not everyone signed in. Everybody wore funny hats and colored beads and talked. But the 3 o'clock toasting for New Year's was the loudest I've ever heard. So it was testament that everybody was having a great time. Did you cook
Yeah.
it? Did you for more?
Thank you for championing. Making it happen.
So thanks to Eileen and Al and Julie for organizing the execution of that.
And we did observe,
Yeah.
A little bit.
little bit, but we did.
So to start with, I want a show of hands because our meeting order is that the speaker comes first and the business meeting after. We don't have it in our bylaws yet, so we need to take a hands-on that we are okay with that process. Okay, thank you. I think we have enough to go forward with it. I think today is a good omen, right? We have a clear night. Maybe it is a good omen for the rest of the night. It has to be today while we are all inside. So hopefully we'll get to catch the clear sky maybe a couple of hours afterwards. So I don't have much to report or such. Somebody asked me if we could have a astrophotography group where we can discuss, people who are interested in, astrophotography in terms of not only, gathering data, but also processing. By the way, I'll be the first customer for that because there is a lot to learn there. As an example, why I like that is because for this month's challenge object, I know that in the area that we were looking at, there's a lot of IFN or the reflection. It's not neither a reflection nebula nor an emission nebula. It's an IFN. So when I started processing, I got the one on the left side. But when you process it correctly, NASMS helped me process it. And you see that, and you say, it's about, I'm sorry, I'm just jumping around here. Maybe I hit the wrong. So it's about 6 hours worth of data. And you can see that the ability to process data is very critical in astrophotography, and it's easy to buy equipments, if you're not building it, but there's a lot to learn in terms of processing. So I'm very interested in it, and if folks are interested in having such a group, maybe we will meet once in a couple of weeks or have a connect with Kerry, and we can take it forward. I think we'll jump into the meeting right now with the speaker, Sean, who will be talking to us today. And I think I won't read all of this, so to keep the meeting efficient, so I think I'll let you read it from the newsletter, which has got all the details. So we'll start the meeting.
Anyway, so I'm here to, first off, nice to see you all. I'm Sean Walker. I'm actually now, as of January 1st, a senior editor at Sky Fellowship. This actually isn't my first talk at the ATMoB Club. I was last here 29 years ago. 1998, I believe I did a talk on astrophotography. Anyway, come a little ways since then. So I'm here to talk about our project called the MDW Sky Survey. Now, okay. Anyway, so our little project called the MDW Sky Survey is a partnership between 3 amateur astronomers. All 3 of us were members of the ATMoB Club, actually. It's David Mittelman, Dennis Cicco, my former colleague, and myself, Sean Walker. Let's see. So our project goal was to map the entire sky in hydrogen-alpha light at 3.17 arc seconds resolution. And that's a big process. It our goal was to shoot it for like about 4 hours, which might not sound like very much, but when you're under really dark skies, it makes a big difference. Anyway, this grew out of several interests. For quite a few years in the early 2000s, Dennis DeCicco and myself were working on exploring wide field imaging as digital detectors got bigger. Back in the early 2000s, one of the first big CCDs, we were excited about CCDs. It's funny that we don't even use those now. To give you an idea, we used a pair like ST8 with a camera lens to get a big wide field. Well, now technology has grown since then. Our first project was mosaicing a 15 frame area of the sky spanning about 4,000 square degrees of the sky. That's about 10% of the whole sky. And we ended up publishing this in S&T back in 2009. This was the result here. And we were using I believe a 6 nanometer H alpha filter and a 50 millimeter lens with this apogee camera, okay? What's really interesting in trying to go this deep, we were shooting it from Dennis's yard in Sudbury, Massachusetts. Anyway, but this gives you an idea of how big that area is on the sky. But when we initially imaged it, we were using that 50 millimeter lens. And let me just go back for just a second, because what really interests me in these projects, are these faint filamentary structures. Besides the really bright nebula, as you can see, like down in the bottom, there's the Orion Nebula and the Horsehead Nebula, although they're really blown out. But you see Barnard's Loop and the SH Nebula, who number I can't quite remember, around the head of Orion. All of that stuff is pretty bright compared to the really faint filaments that you're seeing all around this area. And that's what really drew me into this. So as I go ahead, after we did that, we were really interested in getting higher resolution. So we switched to a higher magnification lens, an 85 millimeter, I believe, or I'm sorry, 110 millimeter lens. And we went a little more ambitious with a 36 frame mosaic. It gets a bigger field of view. Again, each frame we were targeting for 4 hours. The point of the 4 hours is that we don't expose for just one to a 4 hour exposure and then move on. We would shoot with groups of shorter exposures, in this case, 20 minutes. And to get 4 hours, we get 12 exposures. And that's enough to be able to use algorithms that get rid of things like airplanes, satellite trails, things that you don't want in the image. Anyway, and here's the result from that winter's endeavor. Note that it looks like it goes deeper. I think it's a slightly faster lens too, but it resolves more of that filamentary structure, like in the lower right there. That's called the Eridanus J. It's part of the Eridanus Orion superbubble, which is the whole nebulous region you see along the bottom half of this image. This is just to give you a comparison between the earlier version and the new one. As you can see, it goes a lot deeper and resolves a lot more. Anyway, this is the whole thing. This is actually to scale. Dennis took a panorama above his house, and I registered our mosaic to the sky. And that's, if we had hydrogen-alpha eyes, you'd see that. And really big.
Sean, where are you going to sign H alpha?
656.3 nanometers, I believe. Anyway, it's a thin slice of the red, the red end of the spectrum, where hydrogen is ionized. Right. Anyway, as I mentioned, I'm really interested in the faint stuff, and I pushed this image just to show you all of that really faint filamentary structure, and things like the unnamed objects or squiggles at the middle left, really intrigued me. So, in 2015, Dennis, myself, and David Mittelman were kicking around ideas of how to continue our H alpha work. We've shot the same area of the sky twice at progressively better resolution. But, what else did we want to do? We experimented with the 200 millimeter Officina Stellare regarding its Honda astrograph. That rolls off the tongue, doesn't it? Anyway, and Dennis programmed and shot a 30 panel mosaic of Cygnus with this in the summer of 2015. Here's the results with that, and it gets a lot more small scale detail because we're using an 8-inch optic. And what we discovered with this little project is that with the higher magnification, the stars start to kind of get out of the way, and you can see more of the faint or tiny filamentary structures of nebulosity. So that was really interesting. Now, there was a couple of limiting factors to this little experiment, though, is that, well, shooting up in New England, it's, even though we're using H alpha filters, they block a lot of light pollution, but they don't block it all. So you're still limited by the sky background, okay? The other things were, the 16803 detector of our camera was larger than the corrected field of this telescope, so the edge stars were distorted. And then finally, every night we had to keep tweaking the collimation on the telescope. So that wouldn't work, especially if we wanted to, send this in and do a remote project. So as we were discussing it with David, he suggested that we not limit ourselves to a certain area of the sky. We could perform a systematic survey of the sky, shot remotely from a dark sky location using off-the-shelf technology. Now, one of the reasons is that at the time, and still to this day, except for ours now, all sky H alpha surveys are very low resolution. Like the most popular one that you can find online is the Finkelbender Shasta survey. Sorry. Anyway, it's very good and it's tantalizing, but it's still extremely low resolution. Our first mosaic was actually much higher resolution than this project was.
What year was that done?
I think that was in the early 2000s, and that uses a whole bunch of different equipment. It wasn't actually shot by one team. It was gathering different people's projects to turn into an all sky image. Okay, which makes a great map, and it gives us an idea of what we could do. Now, he was already a member of New Mexico Skies and had founded several observatories for colleges and private use. So he's pretty experienced with setting up these kinds of projects and whatnot. Here's a picture of his website with some of his endeavors, including our survey on the right there. He set up. He had the Mittelman Observatory with the 20-inch plane wave CDK down there, an FSQ, and the Bowler and Shivens 36-inch Newtonian, along with the Planeway 17.5-inch CDK that you all know from the club. His family donated it to the club a couple of years ago. I think about 4 or 5 years ago, right? During the pandemic. Right. Here's Dave. I think this picture was taken at the groundbreaking of the building for the Bowler and Shivens. Yeah. And there's the Bowler and Shivens sticking out of its giant observatory. You might recognize this guy at the bottom left there. He's sitting in the front row. So anyway, we decided to really go ahead with an all sky survey plan and really began plotting our attack here. We settled on 2 AP 130 Starfire apochromatic refractors, which, if you know anything about AP scopes, At the time, they were a little hard to acquire, especially having two of them. We were going to pair these with the biggest CCD at the time. This was before CMOS detectors actually were good enough for this kind of work. Before about 2020 or 2019, CMOS detectors had a real problem with thermal noise and with what is it? Amp glow. And it would make it really difficult to take deep images with it. So that's why we chose the 16803, which was a very large detector and fairly good sensitivity. And we just settled on putting these down in New Mexico, where the skies are pretty dark. Dennis went to work on building the imaging rigs. The reason is we weren't going to just use the straight focusers that they had because, we only needed them to move a little bit. We replaced the focusers with FLI Atlas focusers and to eliminate dust being able to get into the system. He also machined and designed filter holders where basically it would be sealed and we wouldn't be getting dust throughout our plants here, as I just mentioned. Here's a picture of some of the work that he did machining these parts. It's pretty complex, and this is the filter holder. It secures the filter right there, and there's no moving parts, so we've less problems to crop up over time. Anyway, here's one of the scopes as he was testing it out, and it's basically they look the same nowadays, except for they're on a different map. And we have a different auto guide here. This is the two with all the cameras on the back end. Now, let's see, cable management was a lot of fun too. Yeah. So planning and executing an all-sky survey shot unattended required some custom software. At the time, in 2015, when we were putting this all together, there wasn't a lot of software for automating these kinds of big projects. And there was some professional stuff, but none of us had experience with that. So we went with what we could. And at the time, we settled on using ACP by TC3 Dreams. It's called Astronomer's Control Panel, which automated everything. We were able to upload scripts of our targets and whatnot. The other problem was being able to actually plan all these observations. First, we were using the SkyX, which had a built-in mosaicing program, mosaicing feature. Unfortunately for it, it was only designed for doing like telescopic mosaics of like single galaxies with do 4 frames of M31. Whatnot. And that's fine, but as you spread across the sky, it wasn't considering the three-dimensionality of the sphere of the sky, and fields were rotated, so it wasn't working out. So we went to Steve Bisk and helped program a new overlapping, a new mosaicing feature so that it took care of all those issues with it. The original thing wasn't helping out, but after a couple of experiments, we were able to, plan this and test it out, and it worked great. So we went with this. After breaking up the sky, based on our detector, our telescope gives a 3.5 degree field of view roughly. With the CCD detector, okay. That calculated out to be 4,120 fields to cover the entire sky. If you do the math, that's a lot of exposures. Anyway, but we were undaunted, so we went off and got to work on it. Now, we initially just put both of the scopes to work down in New Mexico, and we discovered, with our altitude limits of, say, about 25 degrees above the horizon, we could shoot all the way down to minus 33 declination. That's pretty far south. Of course, we can't see that up here. Anyway, So after a few months of testing, we began operations in mid-June of 2016. And here's the scopes, ready for a night of observing. Obviously, it's a cloudy day at the time. But they were both on Paramount. I believe these are MX Plus mounts, and they work great. Over the course of 10 years of using them, I burnt out 2 mounts. We had to have the gears completely replaced. So here's a view of the observatory, with the scope. The FSQ is the scope in the background there. And we were using that for doing a different project, and then for doing follow-up exposures of and color exposures of some of the fields that were more interesting. And you'll see a few of those in a moment. The gentleman in the picture is I believe that's Aaron Salisky.
It's David.
Oh, that's David. Okay. Not long after commencing operations, though, unfortunately, David was stricken with an aggressive form of cancer. To help uplift his spirits, though, while undergoing treatment, Dennis and I put together what exposures we had been able to capture in several months that we were going, and release those and put up a website to show off our endeavor. This is a quick mosaic of what we had done at the time in 2017. And that's like the summer sky spanning to almost the winter there. You have Cygnus on the right, and going all the way down to Auriga all the way on the left, with a lot of holes at the time. With those exposures, I was able to start pulling out and see some of the fields where we got enough data. We were able to stitch together, and I was able to stretch and process. This was kind of interesting, this image here, because it revealed all this nebulosity from in the Milky Way of hydrogen alpha that goes all the way over the M31 here. And this became an APOD back in 2017. There's the big nebula on the left side there is called Sivian 2. We'll get to that in a minute. Unfortunately, David passed away in May of 2017. However, his family was very excited with the work that we were doing and allowed us to continue. Sorry, asteroid 16779 is Mittelman is named in David's honor. The time span initially to complete this project was estimated to be about 5 years, but it's looking close to almost exactly 10 years from the start date to be finished. In the past 9 years, though, we've accumulated about 8.5 or 8.8 terabytes of data. That's not even counting the calibration frames. Due to the nature of the ACP script, the survey targets the best place fields each night in 1 hour blocks. So, it wouldn't just keep shooting this and then move on to the next one. They would just, every night, you would find the best ones. And, that way we're not shooting things over that's low on the horizon. We're also mostly shooting things as they were transiting across the meridian. Here's some of my early uncalibrated results. This is SH2-126. It's a really big nebula in Lacerta. To give you an idea of how big it is, here's the entire constellation of Lacerta. Yeah. Sorry if that's a little dark. I can't see it.
See it, okay.
Okay.
Screen's up top. Go pretty good.
Okay. Right over here, this is what is this? Simis 147 in Taurus. However, this picture right here is from our original mosaic. And I'm showing you this so that you can get an idea of really what the image scale difference is when you're using a 110 millimeter lens versus 130 millimeter lens. just you're able to resolve so much more filamentary structure. And the stars, as I said, they just get out of the way. This is a 6-panel mosaic from the survey data. Over here, here's the Seagull Nebula with the 110mm lens. Now note the extensions from the traditional, what you think is the Seagull. And here's the image from our survey data. I'm just fascinated by all this filamentary structure. It just mesmerizes me.
Those balls in there, those aren't stars, right? Those are just balls of gas.
Those are other nebula, yeah.
Other than.
Yep. I'm not sure of the designations of all of them, so, but I think there's several designations in the Seagull, which is what NGC, or is that IC 2177? Hey, not important right now. I wonder if anyone can identify what this field is. Any guesses? Or just guess what that star is. That's Vega, and this is
Oh, yeah, I was gonna say, I could just say Lyra, yeah.
yeah, it's the entire constellation of Lyra. It's just permeated, filled with nebulosity. Most of these are arcs coming from Cygnus, the great nebula in Cygnus there. Here's zoomed out a little further. This is showing you from the edge of Cygnus, all of Lyra, and into Hercules. And then we zoom out further, and we have all of that, including Cygnus, Vulpecula. I think Delphinus is in here. It's just amazing, how much more you can see as you build out with these images. I kind of thought that the monitor might be a little dark, so this one's a brighter version of the same image. Just to give you an idea how much stuff is filling the area in the sky. This is the constellation of Sagitta. Okay, but what's interesting, let's take it away, get rid of the constellation area. And the bright object in the top right, that's the Dumbbell Nebula. What's also cool is to the middle left is the open or globular cluster M71. What's also interesting is it's surrounded by this really large diffuse cloud of nebulosity that I believe the cluster is the stars in the area are burning it off. Here's Cedarblad 214. I think that's up at the border of Cassiopeia and Cepheus. Zooming much further out, this is showing you all the area of Cassiopeia into Perseus. And as you can see, there's the Heart and Soul Nebula. And if you look below the Heart Nebula, you can identify the double cluster. What's interesting there is note all the hydrogen nebulosity around there. Here's the constellations of Cassiopeia. One of the projects that I'm considering doing after we're done here is publishing a book of all the constellations in H-alpha. Not going to put the right ascension and declination lines on it like this though. But yeah, here's all of Triangulum. That's M33 on the right hand side there. Now here's the double cluster, and as I showed you with that hydrogen nebulosity around there. I shot this with the FSQ as a follow-up observation and used the survey data to enhance it with the H-alpha. The double cluster is actually burning off all of that nebulosity in the area. Here's the Veil Nebula, as I showed you earlier. Once again, it's less starred because they're much smaller. And this is when I remove all the stars. It can really show you a lot more of that nebulosity, fainter stuff in the field.
Sean, what are you using for processing in general?
I use a couple of different programs. For just stretching data like this in black and white, I'm using a simple program called CCD Stack. I use PixInsight for some things, but mostly for these quick and dirty stretches, I'm just using CCD Stack because it's really easy and it has a nice, simple
The whole program,
digital development.
surprised that still runs.
I know. So anyway, here's that nebula I pointed out next, that's near M31. This is called Sibian 2. It was initially discovered in 1972, and ours was the second photograph taken of it. Here's a color version with RGB provided by my friend Rogelio Bernal Andreo. Here we go a little further to the east here and nearer towards the pole. We have parts of Perseus and into Camelopardalis. What's really cool is the nebula in the top right. It's a bow shot from the one of the stars that I can't remember its name right off the top of my head, in Camelopardalis, that's actually racing through, plowing through the medium there and creating that bow shot. Or a color picture we'll show you in a moment. Here's a familiar field of IC 443 and 444 and NGC 2174 in Orion. Zooming out a little further, I wanted to show you all this area because these nebula are actually surrounded, you see it on the left there, by a large ring of nebulosity. As I push it out a little bit further, it becomes a lot more visible here. Now, this is something that happens in a couple of places in the sky, and it's very similar and really large. And it requires, this kind of really big field of view to see this thing, this type of stuff. A similar place is in around the Eagle and Omega Nebula in Scutum, I believe. Anyway, it's similar thing. As you can see, the bow shops around the going around the left to the lower left there.
When you classify this nebulosity, is it IFN?
No, it isn't. I'm only shooting in H alpha, so they're related but different. Okay, IFN is dust mostly that's reflecting reflecting the light of the stars of the Milky Way, not individual stars. Yeah. That term was coined by Steve Mandel back in like 2006 or 2005. Anyway, right here we have the California Nebula, which looks nothing like California. I call it the scimitar. And then here we go to the heart of Cygnus here with the butterfly and the Crescent Nebula. And again, here's the entire constellation of Cygnus without lines. This is here's the Crab Nebula, and that gives you an idea of the image scale that we're getting with this system. This is at 100%, so we're resolving all the filamentary structures. We're at just a high enough resolution that we can detect a lot of small planetary nebula and differentiate them. Here's the M83. Yeah. A lot of these galaxies are just loaded with hydrogen alpha.
What is the aperture of the scope that's used for most of these?
5 inches. It's an AP 130.
AP 130.
Yeah. So assembling a lot of these mosaics, the easiest way was using a program called Microsoft Composite Editor, which unfortunately Microsoft discontinued a few years ago. It worked really well where you just dump your images in and hit go. But it had a limit where after about 200 frames it would choke and start messing up. But it was good, in that. Here's a good example where I dumped in all these images in the southern hemisphere area called, and I threw it in, and after about a half an hour, it turned out this.
Wow.
Yeah. But for bigger areas and the ones that Microsoft ICE wouldn't stitch together. ICE liked areas with nebulosity, did not like just star fields. And it wouldn't stitch them. For bigger areas, I'm using a PT GUI, which is a manual stitching program. As you can see in the middle, those green and different dots are matching stars in 2 images. I had to do it for all of these. This gives you an idea of what it's like. I was working on a big mosaic, which I'll show you in a minute, which turned out to be 600 frames, the panels. That took a long time. By the way, if anyone has any good suggestions on automatic stitching software, I'm all ears. Okay. The image scale of the survey also lends itself to revealing large structures, as I mentioned a couple times, that aren't visible with lower resolution instruments. And professional astronomers take notice when you take pictures of their stuff and that nobody else has taken photos of before. So while assembling a mosaic of fields in northern Cepheus, I noticed some bow shocks that continued through several fields. And I ended up stitching them together. You can see this large blob in the middle with a kind of tower going out of the top there. This turned out to be a suspected supernova remnant called G107.0 plus 9.0. Boy, that's a sexy name. Anyway, noted in Rosat X-ray data. Our image was the first object of it recorded at optical wavelengths, and the data led to being identified for the brighter areas were identified for targeting for spectra in large scopes. And that led us to be part of the discovery of several of these large supernova remnants with Robert Fesson of Dartmouth College. So we published a paper on that back then. It led to a few of these too, actually. Here's another one called G70. You can read it. Anyway, but this one's really interesting. Kind of looks like a big heart. The real kind of heart. Anyway, and also we published papers on these also. So we got a lot of actual real science out of this already. And we weren't even a quarter of the way into the survey when we were producing these papers. Here's another object that you might have heard of called the Ursa Major arc. Maybe not. It's that, well, big curve that you see going through the field here. Here it is in negative, which was a little easier to see for some people. And that also, ended up as another publication. So, hey, we got our names on a couple of things that will exist after I'm long gone.
Ultraviolet.
Yeah. I'm sorry. Yeah. Right. It was also picked up on on what is the
Rosat?
was Rosat doing? I thought that was just X-ray. It was also you gotta read this paper. It'll explain. Oh, Galax, there it is. Yeah. Fesson asked us if we had seen this in our data, and I said, yeah, I thought it was a mistake. But and we ended up publishing another paper on this. Hey, look, had a story on my own website. But that gives you a really good idea of how big that area is too. Yeah. Here's another really large filamentary structure. I don't know what the name of this one is. I forgot to label it, sorry. But here's a more recently discovered supernova remnant in Monoceros. If you can see maybe the big arc on the top there and along the bottom.
Wow.
Okay. But that's not the only one that we were concentrating on here. I was asked to shoot it for that. But if you look and there's this, well, besides the bright object in the middle, there's this roundish, nebula to the left, to the right of it. So I targeted that for several hours. And it's just barely there in the initial data, but when I subtract the stars, it pops out. Okay. And this turned out to be a supernova remnant called G181, and it was discovered in 2016, again at radio wavelengths. This was the first optical confirmation, and once again, it produced another paper, which is pretty neat. Now, after many years, we decided to return to the data for the Orion Eridanus bubble with our new survey. Once I completed that area, I showed you as I was stitching it together. That was the original survey result of the bubble there. And it's gonna go, there we go. And this is, 600 panels of the survey data. And once again, what fascinates me is the really thin filamentary structures going off the bottom. This the latest version of the survey that I'm showing you here, it's leading to another paper showing that the bubble is bigger than what they initially thought. This is a close-up of the area at the feet of Orion in that bubble picture, and I was fascinated by all these little cometary globule kind of structures.
Can you go back one?
Sure. Do you see it along the bottom, below, middle bottom?
Yeah.
Taking away the stars makes it, again, a little easier to see some of these features. As I zoom in, here's some of those
Pillars.
pillars and things like that. And then here's a color version that I took. Follow up with the FSQ. The rays coming from the top right are from Rigel. In winter 2022, David Zalisky and Arnie Hendon were brought in as project manager and programmer to help us manage the expansion of the survey to the southern hemisphere. Arnie identified Obstec Alsace Observatory in Chile as a great site for locating our scopes, and it turned out to be better than we could hope. To give you an idea, there was a good 4-month period where I never was able to turn off the scope. Like every night was clear. It's just unbelievable. Does any of you know Adam Block,
Yes.
astrophotographer? Anyway, he put his scope next to ours because it's really great skies there. Anyway, also shortly after he joined, David helped arrange the partnership between the MDW Sky Survey and Columbia University to use the data for studies on stellar evolution by Mary Putman and David Sheminovich, and also to provide a site for us to make the data freely accessible. One of David's ultimate goals for helping us taking on this project was that we were to publicly, release it. Our ultimate goal is to make our map basically the one that you look at when you want to go targeting H-alpha objects in the sky. So eventually this stuff is going to appear in your favorite planetarium program, maybe in the next year or two. So currently the students at Columbia are also refining the photometric and astrometric precision of the data. They're getting a lot more science out of this project than we initially planned, and that's great, isn't it? Our goal was really just a big, pretty picture, but we knew there could be a lot of science had by it. Here's some of the astrometric reduction, deltas and pixels. I don't know really what that means. Anyway, and then the photometric calibration. Right now they're working on what is informally called normalizing the data so that everything is at a base level. And here's a measurement of showing the HR color versus the galactic latitude. The variation appears to be as expected. So Yay, our filters are accurate. And of course, mapping faint filaments of nebulosity. This is one of the graduate students, Daniela Fern. She was working on making these maps of the nebulosity in the regions. They also were measuring the sensitivity of the chip.
Sure.
Anyway, in the meantime, AP1 recommenced operations in Chile down in August, and that's one of the pictures that it took. It's like that's in southern Sagittarius, which doesn't sound very low, but that doesn't really get over the horizon here. Here's the scope on down in Chile. Now, when we shipped the scope down to Chile, it's actually a lot more economical to buy a new mount and ship it there than to pack up a mount and ship it from the US.
Really?
Yeah. So we ended up taking advantage of that and switching these mounts down there to a plane wave, to the L350 one arm fork. Anyway, they work out really well. An advantage of using these was that you don't have to do any pier flips. You can shoot right through the meridian and just keep going. It worked out really good. The detriment to them is they're a little more wind susceptible to the wind. However, down in Chile, it's very stable and the seeing's excellent. Here's the scope in action. There's actually two of our scopes there. You can't really, it's hard to see, but it's behind the far left behind that casa grain. AP1 and AP3 were operating at the time. So once we shipped the scopes down to Chile, we really started sweeping up the rest of the sky rather quickly. As I mentioned earlier, 3,180 fields were targeted from New Mexico. Oh, that left only about 900 left to shoot from Chile. So it took us basically about 2 years, and we finished that area of the sky. Here's one of the objects in the southern hemisphere called the prawn. And of course, here's Eta Carina, another fabulous object. Yeah. In the fall of 2023, a third telescope was fabricated with the help of Alan Zaleski, and who converted Dennis's designs into CAD and helped had all of these parts manufactured. Completed in October 2023, AP3 began operations in Chile in February of 2024. So we had 3 scopes down in Chile at the same time, so we were able to sweep up the southern hemisphere quite quickly. In the meantime, besides that, in January 2024, we had the data release 0, basically a proof of concept release at the AAS January meeting. This was a 238 panel region of the sky where we've made all the data available on our website. Here's the area, familiar zone, because it's, well, very flashy. Anyway, but a year later, we released the first half of all of our data, which is 2,118 stat fix files available for download. Okay, everything from 0 declination up to +90. Now, any of you can go on the website and download it and process it and do whatever you want with it. It's a lot of fun too. It's addictive. Watch out. My wife's always going, "What are you doing? Still on the computer?" Anyway, so here's the website, by the way. There was also a paper released on it. With each of our data releases, you have to publish it. Publish or perish. Anyway. Here's a picture, where you can access this stuff with a map of our completion on the bottom. Right. And here's where when you go to the page, you could select whichever exposure you want or download them all. Anyway, the rest of the data will all be available. Actually, the whole of the survey will be available through the MAST portal, probably by 2027. What we have to do is deal with their really odd naming conventions. So anyway, primary data collection completed on September 10th of 2025. It's kind of a big deal, you know. And after that point, cleanup phase began. Actually, we started the cleanup phase earlier in the year because as our scopes were running out of targets to shoot, they were sitting idle. So we wanted to keep them going, you know, and basically to try and perfect our data. Initially, there was delivered a list of some 2,500 fields, and in the past, I'd say 10 months, we've swept off almost all of it. There's actually less than 527 exposures. We've had a couple of good nights since then. Here's animation of as the fields were completed. Oh, this is going really slow. You know, as we were working on the process. You know, just to give you an idea, each of those frames are one of the one night of images as they were building up. And this is where the survey stands today. Like all these exposures that you see, the red and yellow are what fields that we're retargeting right now. And unfortunately, that's pretty much where the sun is. So right now we're getting like an hour or two data each morning. So
Sean, what was the criteria that you used to determine that something needed to be reshot?
well, two criteria really: background levels and full width half max. You know, you want tight stars and a dark background or a very low ABU background.
I think there was a question that popped up.
Oh, I'm sorry.
Might be on your screen or in the chat or something.
Oh, I don't see it, but
Somebody was asking if you have any ideas of shooting in oxygen 3 or silicon. Was it?
yeah, not us. I don't have another 10 years for this kind of project. You know, again, and we were working at the, you know, yeah. How do I say it? Yeah, it's working on through the generosity of the Mittelman family. Okay, and I wouldn't want to push them further. Yeah, I'm really grateful that they've allowed us to continue this work to the complete till it's finished. Here's a couple of highlights from the southern fields. What I'm going to do is zoom you out on a couple of images here, just to give you an idea of how vast these regions are. Right here is what's called the Pencil Nebula. That's a little area part of the Vela supernova right there. Okay, and this is from one of our fields. Here's the Vela supernova remnant, and that little pencil nebula is well, it looks like a little carrot right at the lower left of the frame here. Okay, this is, I think, is some 30 panels. Anyway, the Vela supernova remnant is huge. Okay, but not nearly as big as the GUM-12 that it resides in. Now, if you look at, you can see the Vela supernova remnant in the middle lower left there, you know, of those filaments. This object, GUM-12, is just immense. It's 36 degrees across. Okay.
How close is it? You know?
Sorry?
How close is it?
I don't know. I'm sorry. I didn't look into that. Yeah. But it's I think it's one of the nearest star forming regions. One of. I'll look into it more. But what's really neat again is all the faint filamentary structures in there in the region. At the very top right is top left. That's a nebula in Pyxis, and the star at the bottom right. Geez, I had it named, but I'm sorry, I forgot it. Here's another one that's really interesting. I'm sorry, somebody was gonna say something.
Just great.
Okay, all right, right here's the Tarantula Nebula, and again, this is a part of the Large Magellanic Cloud. So, zooming out, here's the entire Large Magellanic Cloud. And it's, what's really cool here is you can really start to see that it's a disturbed spiral galaxy, a barred spiral. You know. You see the bar going through the lower middle.
Yeah.
And here's the small Magellanic Cloud, including what's called the Magellanic Bridge going off to the left there.
Mega Centauri on the right.
That's actually NGC 104. It's the second brightest globular cluster, and it's, I gotta say, it's almost as spectacular as Omega. In fact, it's tighter, more condensed. I spent like 3 hours just looking at those in Botswana last year. It was amazing. So this is both of the Magellanic Clouds stitched together, and what's really cool is that band of hydrogen nebulosity cutting across that, which of course is in the Milky Way. Here's a colorized version of that to give you a little better idea. Yeah. Now that we're going to be finished this year, we're hoping to release the last half of our data by the end of 2026, or at least by the January meeting next year at the AAS. And one of my future plans, as I mentioned, is assembling the entire sky for inclusion in planetarium programs, such as, and planning programs like NINA. And that's it.
Thank you.
Question? Okay.
Building on Charles's question about, alternate frequencies. If you were to start this over today, how would you make your equipment choices, and what do you think you would choose today?
Well, first thing I would change would be the detector. Yeah, we were locked in with the CCD detector, kind of towards the end of the lives of CCD detectors, but you can't shoot half the sky in one with one detector and then switch over to another, because you want to be able, the point of the whole survey is for it to be homogeneous data, where this field over here, you can compare it to this one, and there's a baseline that you can go by.
But I mean, if you were to choose a different frequency, would it make sense to upgrade the equipment today, or would you shoot the same?
Oh, I'd upgrade the equipment.
Yeah.
First off, O3 is, well,
Did I switch it up? Do you want me to switch it up?
90% of the nebulosity you see in the sky is a hydrogen alpha. O3 is less than 10%. Okay, and it's a lot fainter, so you need longer exposures. If I have shot O3 with the FSQ and an O3 3 nanometer O3 filter, and it takes a lot of exposure to get the same signal that you have in H alpha. CMOS detectors are far more sensitive, particularly in the blue end of the spectrum too. So they're a lot more efficient on O3, and that's why you're seeing a lot of these new nebulas being discovered by amateur groups like ours. Okay, but most of the other ones that you're seeing are these really neat O3 objects. Yeah, I'd love to be able to do that, but I only got so much time. Hey, Chris.
Sean, what do your calibration frames look like? Are you doing standard darks and
Yeah.
flats and all that stuff?
Yeah, darks, flats, and biases.
All right.
Okay. Because our camera had what's called an RBI problem, we also do what's called infrared RBI flash, where we saturate the chip and then bleed it off. Okay. So, but initially we thought that meant you didn't need to take bias frames because your signal was flooded, and that's kind of true. But we discovered you still see basically the when you push the data as hard as you can, you will see the surface pattern of the CCD. Okay, and I don't have an example to show you, but it looks just like the flat fields that you're taking. except for there's these big arcs across the whole field. And that's taken out by the biases. Okay. Any other questions? Sorry, I'm losing my voice here. I'm an early riser, so this is late at night for me. Anyway, thank you so much for your time.
Next to Rich and Glenn.
The rest. Oh, good. Well, Glenn can't be here tonight.
Today I will give
Barely
it-
here.
You can move it forward or backwards.
Thank
Standing
you.
anywhere you want.
These buttons,
Yeah, on that.
and it's got a little laser thing. Oh,
No,
beautiful.
no.
Okay. Well, happy New Year, everybody. This is just a cold, but I figured I'd keep the elderly crowd here safe. So let's just jump right into this. So the planet roundup, we've got a few planets that are lost in the solar glare. Can everybody hear me with this silly mask on?
Yeah.
Okay. Mercury, Mars, and Venus are, for the most part, unobservable because they're all behind the sun. But Mercury will have the greatest elongation east on February 19th. We have to wait another year to see Mars in its next opposition in February of 27. And then Venus is at superior conjunction on January 6th. It's going to be a good year for Venus. Greatest elongation occurs in August, and inferior conjunction on October 24th, 6.5 degrees south of the sun. And I'm going to be talking about that because it's so cool to look at Venus at inferior conjunction. 6.5 degrees is they come out to be like 13 solar diameters away from the sun. So that's going to be easy peasy to look at Venus at that point. Meanwhile, we've got quite the parade of planets still going on in the evening skies. Saturn and Neptune are setting at about 10:30 in the evening. Saturn solar conjunction and Neptune too, right around the 25th of March. The ring tilt now is 1.2 degrees. So we've come away from that ring plane passage back at the end of last year. And as we go forward until the late 2030s, the rings will become easier to see and then harder to see. But you get the point. Neptune is 3 degrees from Saturn. It's actually a pretty easy object to find. These stars here are really easy to see in your finder scopes. And so once you've locked on these guys, especially this triangle here, you can jump up to these fainter stars, but you can find Neptune pretty easily. And I encourage you to go out and look at Neptune. It's a really cool planet. Not many people take a look at it. We showed it to the folks at that Arlington Brownie Star Party, and they were impressed that I could flash and find. When I've shown Neptune, I always tell people they're about to see the most unimpressive thing of the night. Because it's a little tiny speck of bluish green light. The other thing I remind them is they probably woke up in the morning thinking that their life would be complete only they could see Neptune with their own eyes. So it comes to pass. Anyway, those guys are in the evening sky. So is Uranus, still relatively nearby the Pleiades. A nice, easy find because these guys, this forms a nice triangle with these little guys here. I think this is 37 Taurus right here. So you can pick these up in binoculars and a finder scope, making it a pretty easy object to find. Transits about 8 o'clock. Jupiter, of course, reaches opposition this weekend. Now it's going to be rainy this weekend, but that doesn't mean you shouldn't, wait it out and get out there and look at the planet.
Think about it.
You can at least think about it. That's right. And plan your observing. And of course, to help you plan your observing, I've sent out for January all the Jupiter events, the great red spot transits and the shadow transits of the moons. And to be perfectly honest, there are many more that I don't send you. I try to keep them all between the hours of dusk and midnight to make it easy for us all to get out there and look at these things. And again, a reminder, now that Jupiter's in opposition, go out and look at the moons. See if you can see in your telescope that they're actually disks and not just little stars in the eyepiece. Look at their colors, look at their size, and you can actually identify them without a roadmap, which is why for the last couple of months I've left the names of them off here. But those are the opposition, those are the diameters, the apparent diameters of the 4 big Galilean moons, and that's pretty good. So I want you to get out there and start looking at that. Transit Midnight, of course, 70 degrees in altitude, pretty high up. And There's a special event coming up later this month, on the 26th of January. Callisto the moon Callisto will actually transit in front of Jupiter. And I really want to encourage you to get out and look at that. They're relatively rare. Callisto orbits the planet in 16 2/3 days. The next time we'll have one available to us. Look at that. If next month I'll switch the slide so that the little ants can go up and transit the planet. The reason the transits of Callisto are so much fun to look at is because of Callisto's albedo. Callisto only reflects about 20% of the sunlight that hits it. Yes, sir.
I just wanted to mention early in the morning on Saturday, Callisto is cutting in front of Jupiter.
Yeah,
And it's very closely aligned with its shadow.
because it's at opposition.
The penumbra should be hanging below the, below Callisto. But the umbra will be eclipsed by Callisto during the entire transit.
Yep.
So as I told somebody Bobby nights, it should look like Callisto has a beard.
Okay, perfect.
Unfortunately, the weather does not look.
It's gonna be rainy, and the reason I didn't mention it in my Jupiter events is because it also happens at about 2 o'clock in the morning.
Yeah.
It's kind of set about 2 in the morning.
Already around 4.
Yeah, so I kind of left that off, but if you want some great information about Jupiter at opposition, this morning on Sky and Telescope magazine's website, there's a great article by Bob King. And I would encourage you to go home tonight, click, and go read it. It's got some good stuff in it. Anyway, that one's coming up. Next opportunity, March 17th. But I really, I'll send out an email to remind everybody, but that's a fun one to look at. It looks silhouetted against the planet because it's so dark. It'll almost look like a shadow transit, but it's actually not. It's the moon itself crossing the disk of the planet. It's just kind of a fun thing to observe, to write in your log that you saw it. Pretty cool. The lunar highlight of the month are the Marius Hills. That sounds like somebody I know. Best observed in the evening skies in the gibbous phase, and it's just below Aristarchus. This bright spot here is the crater Aristarchus, and so Marius is right about here. Copernicus, Kepler. And so the next slide shows it up close. It's about a 25-mile wide crater, Marius. I got the button, don't I? There we go. Well, a little bit of a formatting issue, but this crater is about 25 miles across. These are the Marius Hills, and they're just it's a vast field of volcanic domes. You know, when you look at the moon through a telescope, most of the craters you see were caused by impacts, but most everything else is volcanic. The Maria, there were volcanic domes, there were rills, there's just all kinds of cool stuff to look at. And I love domes. And these are particularly easy to see because they seem to be rather steep. A couple of months ago, I think I had the Arago domes up there. And they're very shallow domes, best seen when the sunlight is really low. But these guys are pretty good to look at, pretty easy to look at. And when you do look at it, notice how dark the region is. Yes, sir, John.
I just want to add an interesting fact that
Sure.
one of the 3 canceled Apollo lunar missions at the end was going to be targeted at the Marius.
That's right. I think it was Apollo 20.
I think you're right.
Yeah. But they canceled it.
Yeah.
Yeah, they were going to go to the Marius Hills. Pretty cool. But they're fun to look at in a telescope. So see if you can see those guys. What else have I got for you all today? Regulus is going to be occulted on February 2nd. These are the times out of the Royal Astronomical Society Canada Handbook for Boston. So your times will vary a little bit, so get out there a little bit early. As bright as Regulus is, you won't see this with the naked eye. The moon will be so bright that you really will need a telescope. I bet you won't even be able to see the binoculars. But get your telescope out, train it on Regulus, and whenever the moon occults a bright star, it's really cool to watch. A little harder to see the egress, but it'll happen up here near that's the crater of Langrenus right there.
Seeing Regulus right next to the eclipsed sun in 2017 was cool.
Sure. Yeah, but this will be easier to look at. But I just wanted to make you aware of that. So that's kind of cool. The fun double star, I picked Rigel. You know, of course, we all know what that is right here. It's a rather challenging double star, but it's a fun one to go look at. The brightness difference is about 400 times. Rigel is about 0.3, the B star is about 6.8, separate about 9.4 arc seconds. And what I like to do with Rigel is I kind of use it to practice, at least I think I'm practicing, to see Sirius B. Sirius B is a little wider, but the problem is that the difference in magnitudes between Sirius A and Sirius B is close to 10,000 times. So I can, you know, with almost any telescope, if you can see a 6.8 magnitude star in your telescope, you can probably split Rigel. Then you go over to Sirius and it's just like, you're blown away by all the brightness of Sirius. I've never seen the pop. John Chef and I talked about someday maybe opening up that 9-inch Alvin Clark refractor and see if we can spot it with that. That'd be cool. And I think if you want to go to Sirius and you want to look at it, try to see the pop. One of my buddies in Connecticut, one of the mirror makers in Connecticut, said to me, asked me one time, "What telescope do you need to see Sirius B?" And as I was pausing to process the answer, he went, "You could see it in any telescope." And again, telescope needs to have the capability to see like 9th magnitude stars, but he suggested looking at it as twilight gets darker and darker and darker. And when 8th and 9th magnitude stars pop out, there's a chance you'll be able to see it. Also a trick I want to try this year is around the end of March and early April. Sirius is about 90 degrees away from the sun, where the natural sky polarization is maximum. So I think Sirius is actually pretty easy to find in twilight. It's a bright star, right? Put your polarizing filter in your eyepiece, turn it to darken out the sky, and that'll improve the contrast. That might give us a little bit of an edge to try and spot the pop. It's on my bucket list, and see this? We're running out of years. Right? Yeah, gotta get this underway. But anyway, do check out Rigel B. It's a fun one, and it's kind of pretty. Next one. So the fun variable star. Remember last month I talked about Mira, right? Mira, and the chart only went to here, and I said, "Oh, we're getting close to where it's going to start to peak." There's where it is the other day. So it's gone from, let's see what my glasses. It's gone from about 8th magnitude, 9th magnitude, all the way up to about almost 3.5. It's been really cold outside. Right, it's been really cold, and I'm not one to go out in the cold. But I would encourage you to just take a peek at Cetus and see if you can pick up Mira. It's a really cool star to look at, and then go and read some more about it. It's a fun star to read about. Anyway, there's your variable star for the month. But Glenn would tell me I would be remiss if I didn't mention Moose. I thought I had some times of Algol. A couple of opportunities to see the minima of Algol. This is one of Glenn's favorite double stars. So Thursday, January 29th. About 10:15 at night, and Sunday, February 1st, a little bit earlier. It's an eclipsing variable. You can watch it dip down to its, minima over the course of a few hours, and then if you're so inclined, you can watch it come back up again. And it does that. It's so super regular. It's easy to predict. To get to the challenges, I'm going to go kind of through these pretty fast. This is NGC 188, really, really tough orbit cluster. Did anybody here see it? Because I did. I know I didn't. And we looked with the 25-inch, and we couldn't see it. It's really, really big. But this is a nice picture by Doug Paul. That was his preliminary image, right?
Yes,
I think I've got a few others here.
that's only 30 minutes exposure.
Oh, was it really?
Yeah.
Oh, that's pretty. It's a pretty cluster. I mean, if you can find it, it's easy to find. These stars are easy to happen upon, but this cluster is really faint visually. It's tough to see. So here's Doug. I assume this. Oh, sorry.
That was my part. Oh no, that was my detailed image. Wait,
Yeah.
find it again.
It's got to be here somewhere. There it is.
I can comment on the first one. I think I should.
And this we saw this earlier.
NASA processed it. I think.
And here's all this cool stuff here. That's pretty cool.
Yeah.
And I think there were a couple of images by Mario. Sure, there they are right there. It's a lovely cluster if you can actually spot it. And it's circumpolar. You can see it any night of any year. any night of the year. So just get out there and geez, if you're next time you're under really, really dark skies with almost any scope, see if you can spot it. See if you can spot it. The February challenge. Where's my January challenge? There it is. So for the observers challenge, Glenn and I, we came to the end of the list, right? 2025 was the end of Roger and Sue's list. So we've recycled back to 2009. Good news is that the challenges of 2009 were not nearly as challenging as the challenges of 2025. What that means is I want you to get out there and try to find some of these guys. And we put this one in. Roger's first article with Fred Grayworth was February. And he picked the Crab Nebula, which is, you already saw that in the next slide coming up. So Glenn and I decided to put M74 in there as a challenge object. And it's a tough galaxy to see. The overall galaxy has a surface brightness of about 14. That's hard. The nucleus is probably brighter than that. It is brighter than that. It's probably a surface brightness of about 12. And so go. You won't see the spiral arms visually. But, Doug was able to pick them up nicely in his preliminary image. It's a relatively easy guy to find. Pisces here, Aries here. Actually pretty easy to find. So do get out there and look at that.
It took a little more, that's 4 hours of exposure.
Okay. Yeah, it's a pretty faint galaxy, but it's doable. And so, and here's the February one. Crab Nebula. Supernova remnant 1054. It's faint, it's got a relatively low surface brightness, but if you got a dark sky and you don't even need a lot of aperture, you really need the dark skies for the contrast, but it's a great object to look at. And so there you go. So those are the challenges. The clubhouse probably won't be open this weekend because the weather's supposed to be pretty wet and rainy, but there are the rest of them through the winter. And so do come out and join us.
Right, topic on board meeting, it's coming up. I think everybody who is in the board have agreed to be able to come for that 8 p.m. January 22nd. Members are welcome to attend and listen in. I guess that's about our meeting today.
Thank you.
So the close of the meeting, our next month's speaker, he was the previous chairman here of the Center for Astrophysics. So Daniel Eisenstein will be speaking to us. And he'll be talking something about JWST, and he's busy processing data and so forth. So he wanted it to be scheduled for February, so he's ready for it. So hopefully we'll get to hear more of those analysis. There you go. Happy New Year, everyone, and see you next month.